Hello, and welcome back to Calero Academy. Today, we'll be continuing our series of geometric questions, and it will be involving today this poorly drawn triangle. Okay, so this question asks us to find the area of the triangle BFC. Normally, this would be impossible to solve with only what they give us, that ACB is isosceles, and that it is related, that it is similar to triangle ADE. However, they also give us this extra piece of information, that the area of the kite ADFE is equal to 24. Without that crucial bit of information, it would be impossible to even find the most rudimentary of areas. You couldn't even find the area of the big triangle, ABC. It would just be impossible. You could try to do it until Pythagoras rose up from the dead, but even he would not help you. Okay, so continuing on with the question. First, let's notice that the triangles ADE is similar to triangle ABC. And also that the ratio between any two sides is 20 on 12, or 5 on 3. So, therefore, BC will be equal to 5/3 times DE, and that AH will equal to 5/3 times AG. Now what we're going to do now is just build up a lot of information, a lot of ratios, and a lot of stuff like that. And then from there we're just going to apply it, and then we're going to have this magnificent ending. So continuing, also note that triangle DEF is similar also to triangle BCF, and that the ratio is also from 5/3 to 1. We can see that because the ratio of DE to CB is 3/5 to 1, and we can understand that from our guys over here on this triangle. So this means that therefore FH will equal to 5/3 times, 5/3 times FG. Okay, now we want to find the area BCF is equal to 1/2 times BC times FH. This is just the formula for the area of a triangle, nothing special there. Now also note, we have to remember what the area of a kite is. The area of a kite is equal to 1/2 times the product of the diagonals, or then in this case 1/2 times DE times AF is equal to 24, or that DE is equal to 48 on AF. We'll use that later. Okay, so now what we're going to do now is first let's just get two more ratios, just two more equations, not ratios. First, let's note that AF plus FH is equal to AH from just the height over here. And also that AG plus FG will equal to AF. Both of these, although seemingly very simple, will be of big use to us later. Now, let's just start plugging in the formulas that we have now. So the area of BFC is equal to 1/2 times 1/2 times BC times FH, which equals 1/2 times BC times, plugging in the guys from over here, 5/3 times FG, which will equal to 1/2 times, substituting in for BC, that's such 5/3 times DE, 5/3 times DE times 5/3 again, times FG. Now, what else can we substitute? Remember, we already have an equation for DE too, over here. So, plugging in, we have the area of our triangle is 1/2 times 5/3 times 48 on AF times 5/3 again times FG. Now, AF is equal to, from over here, AG plus FG. So the area of our triangle is 1/2 times 5/3 times 48 on AG. Oh, forgot our little lines on top of our guys. So it's our triangle is equal to 1/2 times 5/3 times 48 on AG plus FG times 5/3 times FG. Now what we're going to do now is magnificent. What we're going to do is find that AG is equal to 4FG, and then we're just going to, all the FG's are just going to cancel out, and we're going to be left with the answer. So, what we do now, let's note, create a little sideline over here. Note that AH is equal to 5/3 times AG. We know that from over here. Okay, so we know that. Now, let's see if we can find another equation for AH. AH is also equal to AG plus FG plus FH. We get that by combining these two equations. We know that AH is equal to AF plus FH, and we plug in for AF being AG plus FG, and we get that AH is equal to AG plus FG plus FH. But FH is just equal to 5/3 times FG. So AH is equal to AG plus FG plus 5/3 times FG. Now, what we do now is just equate. So, on the one side we have that 5/3 times AG is equal to AG plus FG plus 5/3 times FG. And now, what we do now is just do some little cross multiplying, and I'm just going to skip that part, and what we're going to get is that AG is equal to 4FG. And that's beautiful! So what we can do now is just rewrite our area of a triangle as 1/2 times 5/3 times 48 on 4FG plus FG, 5FG, times 5/3 times FG. And the FG's are going to cancel out, and we're going to be left with 1/2 times 5/3 times 48 on 5 times 5/3 again is the area of our triangle. And next, now we just do the simple arithmetic. So you go to 1/2 times 5/3 times 48 on 3, which will equal to 1/2 times 5/3 times 18. Oh, wait a second, sorry about that, times 16. It would be horrible if you went all that way and then you made a simple arithmetic error. Okay, so now we're just really close, and after a little bit of arithmetic, we're going to get that the area of our triangle is equal to 120 on 9, or equal to 40 on 3, which is the correct answer. So, we found the area of our triangle, but now let's look back a bit and think of what helped us to solve this question. The two crucial ideas was to use the similarity of triangles, and then also to use the area of our kite. But another idea for the area of our kite, another way to think about how the area of our kite was useful, is that if you tried to solve this without the area of the kite, you would just be trying to solve a bunch of equations where all the lines were parallel. With the area of the kite, we're given a crucial bit of information of AF here, and AF is orthogonal to orthogonal to the bases of these triangles. With that extra bit of information, we can use that and at the end cancel out a lot of things. And with that, we end this Calero Academy production. Thank you for watching, and this has been a Calero Academy production. We hope you come back for more. And now, Calero Academy will now start taking comments. And if you want to if you don't understand something, you can just put it in the comment section and we'll address it in the comment section. Or if you would like us to make a video, you can just type it into the comment section and we'll see if we can make one for you. Thank you for watching and hope you come back for more. Goodbye.